So first discussion is about range-based programs. So what are the range-based programs? In the last class, we have seen that just printing the multiplication table for one number, checking one number is a prime number or not. Let's say find the factorial for one number. Check one number is a perfect number or not. Range-based programs are very, very easy. All we need to do, only adding one outside loop. That's it. First one, I just want to print multiplication table for one number. Just for only one number. Int n is equal to, this is table number. Later we will decide. And you know that already we discussed how to display multiplication table. We are repeating for loop. Table we need to print 10 times. I equals to 1. I less than or equals to 10. I plus plus. I plus plus. Here, printing the table, percentage D is multiplied with percentage D equal to percentage D. Table number, I value and table number into I value. This we already discussed. Simple. N is equal to 5. Then it will print fifth table. Let's say N is equals to 13. It will print 13th table. 13th table. But the question is, sir, I want to print in the given range. N value is not 5, N value is not 13. So this will print one table, na? One table. Now just write one loop. N value equals to 5, N less than or equal to 10 and N plus plus we are writing. When you are writing this, look at this. Fifth table, sixth table, just one minute. This is basically an escape for loop, right? Yes. Whenever you are placing outside one loop, this loop is to print one table. But whenever you want to repeat this code, then we need to use outer loop. So what will happen now? First n value is a 5. 5 is less than or equals to 10. Condition is true. It will come inside. It will print the fifth table. Next n value becomes 6. Then it will print sixth table. N value becomes 7. It will print seventh table like this. Fifth table, sixth table, seventh, eighth, ninth, 10th. This we already discussed in the last class itself. Today concept is range-based programs means what? Just adding the outer loop. This one. For example, sir, I just want to find factorial for the given number. Let's say n is equals to 5. 5 factorial means 5 into 4 into 3 into 2 into 1 or 1 into 2 into 3 into 4 into 5. It's, of course, anything will give the factorial. Taking one variable, fact, n factorial means what? N times we have to repeat the loop. For n is equal to, I is equals to 1, I less than or equals to n, I plus plus. How many times? N times it is repeating, like 5 times. So we need to do 1 into 2 into 3 into 4 into 5. So every time fact is equal to fact into I. We are just multiplying. After that, clearly we are printing n factorial is that factorial value. N comma fact. N means what? 5. Output is a 5 factorial is. See, every time I value is multiplying na. 1 into 2 into 3 into 4 into 5. 120. Output is a 5 factorial is 120. Sir, let's say I want to find out that 6 factorial. 6 factorial is a 720. Sir, I don't want to print one factorial number. I want to print in the range. See, look at this. Same story. N value is now not a single value. N value, let's say, starts from 2, 2 factorial. 2, I want to find out 8 factorial here. So first N value 2, it is finding that 2 factorial. Next N value become 3, it will find out the 3 factorial. N value is a 4, it will find out the 4 factorial. Here one important point is every time fact value starts with 1. Let's say if you are finding 4 factorial, 24. 24 given. Next you are finding that factorial 5 factorial. 5 factorial again fact starts with 1 only, not 24. So 1 into 2 into 3 into 4 into 5. So when you run this, look at this. 2 factorial is 2. 3 factorial is 6. 4 factorial is 24. Clearly, the factorials of each number is printing. Let's say one example. Sir, checking one number is a prime number or not. In the last class, we discussed clearly. What is the factorial? I mean, what is that prime number? The number which is having two factors. Let's say I'm counting the factors. Loop I am repeating n times I equals to 1, I less than or equal to n I plus plus. Every time checking if n is divisible with I or not. If it is divisible, increase the count. This is last discussion only. Outside what we are doing? If the count is 2, if minimum it has 2 factors, yes, the number is a prime. Let's say n value is a 7. Is printing that 7 is a here n. It is saying that n is a prime number. 7 is a prime. 7 is a prime number. But now the question is, sir, I want to print only prime numbers from 1 to 50. Not one number prime or not, we are not checking. Simply for the number starting with 1 is less than or equals to 50 n plus plus in the given range. In the given range 1 to 50. Now first n value 1, counting how many factors are there for 1. For 1 count is 1 only. It's not prime. For 2, yes, 2 is a prime, 3 is a prime, 5 is a prime, 7, 11, 13, 17. Look at this. Only prime numbers are printing. Only prime numbers. Then that last example you also practice because perfect numbers. We already discussed that. So what is a perfect number? What is a perfect number? Sum of the factors except itself. In the last class, last discussion. Sum of the factors except itself is equals to the same number. Let's say n value 6. N value 6 means total how many factors are there? 1, 2, 3, 6. But except itself, remaining factors 1 plus 2 plus 3 again will give 6. So the given number and sum of the factors except itself. 6 is also factor, but no need to check with itself. This is called what? Perfect number, na? So you are not finding the count, you are finding the sum. And no need to check with itself. So it's less than n, not less than or equal to n. If you are finding that factor, just add that factor to sum. Sum plus is equal to I, or sum is equal to sum plus I, anything. Output is what? If the sum value and given number both are same, it's a perfect. Yes, of course, 6 is a perfect number. But in interview, a very important question, between 1 to 10,000, how many perfect numbers are there? So, same only, just outer loop only you need to add. For n value 1 to 10,000, 10,000 times the code will repeat. 10,000 times. Checking how many perfect numbers are there. Only 4 perfect numbers are there. 628, 496, 8128. From 1 to 10, only 6. From 1 to 100, only 28. So from 1 to 10,000, only 3. That is 496. Like this. A little important question they are asking in every way. Display perfect numbers from 1 to 10,000. This is the range-based program. Please do this. Right. So next one is a pattern programs. Let me explain what is a pattern. Pattern means representing the data in two-dimensional format. Two-dimensional means what? Is a rows and columns. Two-dimensional means rows and columns. We are representing in rows and columns. Here, outer loop is representing number of rows. Let's say I'm taking I equals to 1, I equals to 2, I equals to 3, 4, 5, 6, 7, 8, and 9. Columns J equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 rows and 9 columns we are taking. Number of rows and number of columns. Total 9 rows and 9 columns. Two loops required. Let's say I and J. So I'm taking two variables I and J. For I equals to 1, I less than or equals to 9, I plus plus is 9 rows. When I value 1, J 9 times will repeat. For J equals to 1, J less than or equal to 9, J plus plus. Inside just printing that star. Just a star printing. But what is the problem here? When I value 1, 9 stars will print happy. Next, when I value 2, again J repeats 9 times 9 stars, but side by side will print. Side by side. Our problem is what? After printing the 9 stars in one row, after printing the 9 stars in one row, we need to send the control to the next line. Nothing but after this, after printing 9 rows, send the control to the next line. Look at this. In the first row, 9 stars. In the second row, 9 stars. In the third row, 9 stars. Rows and columns. So exactly in the square format, if you want, right? Just one extra space, that's it. This clearly is displaying like this. This is printing the simple pattern. But sir, I just want to print, I just want to print only in the fifth row and in the fifth column. Just fifth row and fifth column. Look at this. Now I'm printing on conditions. Row means I, column means J. If row means I equals to 5 or J equals to 5, then printing that star. Else space. Else space. Look at this. Fifth row and fifth column. If you just remove this column, only in the row it is printing. But remaining space is important now. So else block is compulsory. Spaces. Fifth row, either fifth row or fifth column. Plus is printing. Sir, let's say I want to print in the first row, in the first column, in the last row, and in the last column we are printing. Easy. I equals to 1, first row. J equals to 1, first column. I equals to 9, last row. J equals to 9, last column. Like I just want to print only borders. I just want to print only borders. Rows and columns, borders we are printing. Next one is, see, this is a little important. Sir, I want to print this one. Look at this. When I value 1, J value 1, at that intersection point, 1 star. I value 2, J value 2, at that intersection point 1. I value 3, J value 3, at that intersection point 1. It's very simple. When I and J are equal, when I and J are equal, so just I equal to J. That slash is printing. Let's say I just want to print this one also. Now observe this. When I value 1, J value 9. Here we need to print star. When I value 2, J value 8. When I value 3, J value 7. When I value 4, J value 6. If you observe this, 1 plus 9 is a 10. 2 plus 8 is a 10. 3 plus 7 is a 10. So that simple formula, I plus J equal to 10. Like that, we just create the expressions and display. I plus J equal to 10 or I equal to 10 minus J, J equal to 10 minus I, anything will work. Let's say this is a plus I, this will become minus I. It's almost the same output, will not change. Just like maths, expression creation, that's easy, you can understand. Got it? The next one is, the next one is here, here now, yes, here now. I just want to print this line. What is this line? I is equals to 1, complete line. I is equal to 1. But sir, I don't want to print up to the end. I want to stop here, here. J value up to 5 only. So, and J value is less than or equal to 5. I value 1, but j up to 5 only printing. That is. Next one is, I just want to print this line. J na? J equal to 5 or j equal to 5. See, complete line is printing. Look at the next one. I just want to print this line, only half. Complete line means what? I equal to 9. I equal to 9. But only half na? See, before means j less than or equal to 5. After means j greater than or equal to 5. J greater than or equal to 5. Next one is, I just want to print this line. What is this line? I equal to 5. Here, I equal to 5. Next, I want to print this line. What is this line? See, j equal to 1. J equal to 1, straight line. But I value only 5, 6, 7, 8, 9. J equal to 1. But I greater than or equal to 5. And finally, I want to print this line. What is this line? J equals to 9. J equals to 9, ninth one. But I value up to 5 only. J equal to 9. But I value is less than or equal to 5. So this one is printing like this. This one is printing like this. Let's say, just wait. Open. Now, so based on this one, oh, there's that. ఒకసారి this one, this one, this one, this one, and this one. Now, so based on that, you need to do, right? You need to do things like this. One is just printing that swastik. Exact swastik you need to print. This one, just a small changes. And next one, you just try to print this one. This one. And one more thing. And one more thing. You need to print this one. Just these are the programs you need to finish. Got it? These are the programs.